we're just specifically looking at the difference between what a relation is and then what a function actually is defined by, okay? And so a relation is just going to be like a set of ordered pairs, okay? That's what's going to go in that first blank, okay? Oops. Okay? And a function is a little bit more specific, okay? And it's a relation, so there's like, you have like the family of relations, and then underneath relations you can have like things that are functions and not functions, right? And so we better have a way to like check whether or not something is truly a function, and that's what we're going to explore today, okay? So basically, you can call everything kind of a relation, and then whether or not something's a function, you're going to use a test to check that. Okay, and a function is defined by, it's a relation which, for every, that's the terminology, for every x, one corresponding y. Okay, so for every x value, there's only one corresponding y value. I should probably add the, okay? Okay, I don't think there's a great distinction between a relation and function in terms of the examples that they've provided here. Because this statement is true for both of them. But you will see, as we go through the lesson here, you'll see examples where that's not the case. Okay? Okay, so to determine if the graph of a relation is a function, we're going to use what's called the, three spaces there, vertical line test. Okay? And then underneath there, I suppose, I'll write under the range of a relation is the set of, I'm going to use some other terminology that you probably would have seen in grade 9, dependent elements, okay? And what is the dependent variable on a graph? You only got two variables that you plot typically, for your sake. You've only got two variables on a graph. You've got x and y. So which one do you think is the dependent variable? Do you remember this from grade 9? The one that depends on the other one? Which one depends? Does y depend on x or does x depend on y? Do we remember? 50-50 guess. Yes? Y is the dependent variable. Okay, so the range talks about dependent elements, which is the y values. Okay, you could write a similar statement underneath. Okay, and we're going to, not to worry about it for now, but in a couple lessons we're going to talk about the domain. The domain of a relation is the set of independent elements. Okay, these are all the x values. Okay, does anybody have any issues so far? So we've got two things there really are the important part, which we're going to explore in more depth later. Sorry, I'll move that up. I see heads start moving around. I know it's too low. So the range is y values. Domain is x values. Okay, that's pretty much the premise there. And we're going to spend more time on that later in more depth, okay? How to actually write it. But for down below here, we're going to determine whether or not the relation is a function. Okay, we'll let everybody get caught up and then we're good to go. Okay, just looking around. Okay, so it's not that it's, well, it's kind of 50-50. If you were to if I gave this to you on a test, you could guess 50-50, but it's not too hard, okay? So you're going to look at this series of points here, basically, right? And you're going to determine whether or not what we've got here, the relation, is a function or not. So what do you think? Based on the definitions that we wrote above, check and see whether or not those ordered points or the points there create a relation, or is it a function? Based on your definitions. What do we think? Well, let's take a look. First things first. Do you see any? This is how I tackle these questions. I look at that. Do I see any repeats in the x values? Okay, if you don't see any repeats in the x values, chances are you have a unique set of points there, right? And by unique, I mean for every x, there is truly only one y. Does that make sense? It's when you start seeing like multiple x values, the same x value appearing in an ordered set, and then having multiple y's. That's your clue that like it's not a function in that instance, right? So this one here appears to look like, okay, well, it looks like I don't have any repeats in the x values, so this one must be a function, right? And to be more specific, or like just to lock that in, okay, there's one unique y for every x value that you see in that ordered list there. Okay, does anybody have any questions with that? We're all right? So then if we jump down to the next question, we use what I just said. Again, this is me kind of examining, this is how I tackle these questions. If I look at that and go, okay, let's check the x values, okay. Oh, well, you look at that, we're good. Oh, then I've got a repeat. I've got two separate points at 1, two different y values at the x value of 1, and I also have two different y values for the x value of 2. So in that instance, that can't be a function, okay? And it can't be a function because you have multiple y values for one particular x value, or in this case, there's two x values that are the same, and they have multiple y values. Does that make sense? So this one's going to be a relation, okay? You could say multiple y values at x equals 1 and 2. Okay. So, if we continue down this road, okay, you can do one of two things here, okay? And that when these ones are a little tricky sometimes. When you're provided a graph, it's not so bad, okay? Now, this is just a series of points actually plotted, and I suppose if you're ever in question and you've been provided with like just a bunch of points, draw yourself a little grid and see if any of them end up doing what ends up happening in C, okay? So you can always just like, if you're struggling by looking at the ordered points, just take 2 seconds, plot them, and then take a look, okay? And you'll see what ends up happening here in C. Okay, so if I take a look at C, I'm gonna jump here and take a look. Oh, okay, I'm gonna use this right here. I'm gonna change the color. I like this. It's quite simple to use, actually, this vertical line test. Okay, vertical line test tells us if I were to draw a vertical line here, how many points do you see on that vertical line? Just one, right? I only see 1 point there that touches that vertical line. That inherently tells me that because there's only, for that particular value of x, that's what a vertical line is. Remember, that would be that blue line there would be the equation x equals -3. So when x equals -3, there's only 1 point that touches that vertical line. And so far we're all right, okay? But if I keep going and I draw a whole bunch of vertical lines, that one's good. This one's good. you're going to run into, when you arrive at x equals 1, it's not going to let me draw that on there. When you draw at x equals 1, how many points do you end up coming across there? It looks like there are 2 different points where the x value is 1. Right? It looks like there's a point at 1, 1, and another one at 1, 4. So if you had this in a list, you would see those 2 points being like beside each other. We know that that's not a function. Okay? Does that make sense so far? Okay, so this one would be that's a relation for C. Okay? And so we could apply this vertical line test to all sorts of different things. It could be a series of points. It could be actual graphs of things that you recognize. So if I were to draw this, and the test just tests whether or not there are the graph or the series of points crosses that vertical line at more than one spot. That's what this does. So at any point in B, if I just drew any vertical line along there, how many times does that circle graph cross the vertical line? Twice. So if it crosses more than once, you know that that's not a function. Okay, fails the vertical line test. So this is also a relation. Okay? Now, E, have we seen this graph before? We know what this is called? I think so. I showed the grade 9s this. What's it called? Starts with a Q. Yes? Yeah.
Starts with what?
A Q.
On Q. Oh yeah, quadratic.
So quadratic. Okay, it's a or parabola. Or parabola. Is that what I sent you for a loop?
Yeah.
It has many names. Quadratic, parabola, x squared. There you go. Actually, that one specifically would be x squared minus something. X squared minus 6 or something. Okay? So let's draw a whole bunch of vertical lines and see what happens. Draw a vertical line here. How many times does it cross there? Once. 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 So this passes our vertical line test. So the graph of a quadratic, or y equals x squared, is a function. Okay? Now also, in this course, again, this is one of these time savers for grade 11. It's not that it's any harder. It's just I'm not going to ask you to do, well, maybe I might ask you to do some stuff depending on how it goes. It'll depend on how it goes as to whether or not I ask you any questions on this. This graph, this is the graph of y equals, and we'll come back to this later, the absolute value of x. Okay, if you haven't seen that before, okay? The absolute value bars just imply that the graph always has positive y values. So no matter what you plug into the equation, if it's y equals the absolute value of -2, if I input a value of -2, it spits out a value of +2 because it's taking the absolute value. It tells you it always has to be positive, okay? And so that, in turn, is how the graph ends up turning out. Okay, we call it the absolute graph. Or actually, in high school, when I had grade 11, we called this the V. My high school teacher had all these names so that we could they weren't the official names. They were just the ones that we could remember the shapes. So when we went to go do stuff to them, we knew what they looked like. Okay. So anyway, function or not a function, what do we think? If you draw your vertical lines, what do you think happens? I think it's good, right? Because if I draw a vertical line anywhere along here, it only crosses once, right? So this is also a function. And then obviously, I'll jump over G for a second. I'll go to H because I think that one's easy too. G requires a little bit of explanation. Okay, a line, also a function. Except for what? So a line, remember this is just y equals like, what? It's mx plus b. This is going to be a function because it passes my vertical line. Oops. It's a function because it passes the vertical line test. But what's the only instance where that's not the case? Or can you think of an instance? Let me rephrase that question. Can you think of an instance where a line is not a function? Yes.
If it's vertical?
If it's a vertical line. If you have a vertical line, like it doesn't matter what it is, if it's x equals 2 and you had x equals 2, looks like something like this. It's at 2 and it's got, obviously if you were to draw a vertical line test on that, it's going to fail it because it's going to touch at multiple points. So that's the only instance where a line would not be a function, is if it was vertical. Does that make sense? That could be a trick question I could put on a test. The graph of x equals 3, is it a function or not a function? Right? Something like that. Right? Now, this one here is a little tricky. I remember these gave me a hard time before because they are kind of hard to follow. These are, I don't know what to call, I call them kind of like mapping statements. They're just like a bunch of points written. Kind of funny, right? So you're going to try and follow the arrows, which is what's tricky, right? So if you were to write a series of points here, you're going to start, I just start at -1 and then follow an arrow over to, oh, we've got -1 and 3. There's 1 point. Okay, and then I'm going to go -1, 4. Now right off the bat, you should all look at that and go, okay, there's got an issue there in terms of whether or not something's a function versus a relation. Because I've had a repeated x value, and then it's spat out a different y value. So right off the bat, I know that that's not a function. Okay, and just for consistency's sake, we'll finish writing out all those points. Okay, you could say it's a relation. And it's because of these repeated x values. But if I kept going, just for consistency's sake, I'm going to have 1 and 1, oops. 1 and 2, 2 and 3, these are hard to read. 4 and 3. 4 and 3. I think that's the last one. Okay? Is everybody all right? Okay? Okay, I'm going to hit stop there because I don't want it to be 45 minutes.